All right, we are on 6.04 today, and that's going to be, we're going to solve rational equations. Meaning today we should have an equal sign. So just bring you back to this chart again. We talked about rational expressions already, and that is when you're adding and subtracting without an equal sign. And that's when that's the only one that's different. So that one's kind of the hardest one here. So you have to multiply by what you need over what you need in order to get your LCD. Then we talked about complex fractions, which are fractions inside of a fraction. And in that case, you would rewrite everything as a fraction and then multiply through by your LCD over 1 to clear out your fractions. And that's the same idea that we're going to do today. And then we also talked about, that's not on here, multiplication and division with fractions, and that's when you would factor and cancel. It's a little blurry. Okay, so first one we're going to do today, we're going to kind of dive in here and write it out as we go. So 1 minus 3 over x minus 3 equals 10 over x squared minus 9 is the given equation. So again, notice that we're adding and subtracting. Here we're subtracting. I can make this into a fraction. And so I'm adding and subtracting fractions with an equal sign. And that's what's really important here. So this is what makes it different than our expressions where you would have just seen that part. And that's when you would multiply by what you need over what you need. So before we can begin, first thing we want to do is factor any denominators that can be factored. So this one right here can be factored. That's a difference of two perfect squares. So I can rewrite this as 1 over 1 minus 3 over x minus 3 equals 10 over x minus 3, x plus 3. Also at this point, we want to determine any extraneous roots. So looking at your denominators, I can tell that I can't have anything that would make my denominator equal to 0. So if I put a 3 in for x, that would make this denominator 0. So I know that extraneous roots, which are numbers that would make your denominator equal to 0. So we cannot have x equal to 3. And also here, if x was negative 3, then negative 3 plus 3 would give me a 0, and 0 times this would give me a 0. So it also cannot equal negative 3. Now, if you forget to do this part, as long as you check your answer at the very end in your calculator, then you'll be okay. But it is a good idea to look at this first before you start. All right, so now step 2, we're going to find our LCD. And then what we're going to do is multiply every term by our LCD over 1. So when I'm finding my LCD, I'm looking at all of my denominators. So this 1, this x minus 3, and this x minus 3x plus 3. Now remember, when you do that, to find your LCD, all of your binomials cannot be split up. They have to come as a nice special gift together. So we have to include all of them. If it comes up more than once, you only have to include it once. And any other single variables you want to look for, which we don't have, and our 1, which we don't need to write, but you're welcome to if you want. So here's our LCD, x minus 3x plus 3. So what we're going to do is we're going to take our original equation and we're going to multiply it through by this over 1. So what I'll do here is I'm going to put, and if you don't have other colors, you could use just brackets here. So that's my LCD over 1 times 1 over 1 minus 3 over x minus 3 times x minus 3, x plus 3 over 1 equals 10 over x minus 3, x plus 3. So in black is my original equation, and in pink is just my LCD over 1. Sorry about that. So now that I've multiplied everything through by my LCD over 1, I'm going to cancel along my diagonal here. So I can cancel because it's multiplication in between the two fractions. I'm not cross multiplying, I'm just cross reducing. So here along my diagonals, nothing to reduce, the 1s if you wanted to, but that just reduces to a 1, so it doesn't really change anything. Here, I can cancel out this x minus 3 and this x minus 3. And then here, x minus 3 cancels and x plus 3. You want to do a quick check, just like we did with our complex fractions, and make sure that everything in the denominator is either crossed off or a 1, crossed off or a 1, crossed off, 1. So now we've cleared out everything from our denominator. Now we're going to rewrite what we have. So over here I have x minus 3, x plus 3, minus. Now, and as soon as you see subtraction, you're going to the bells to go off a little bit, because we want to make sure we don't forget to distribute that negative. So with some students, it helps to make that into a positive and make the 3 a negative. And so now we'd have negative 3 times x plus 3, and this will equal just 10. All right, so now we've gotten rid of all of our fractions. Now we just need to simplify this. So here I have 2 binomials, so I need to FOIL those out. So I'm going to FOIL those to get x squared plus 3x minus 9. And here I'm going to distribute to get negative 3x minus 9. Combine my like terms, these cancel, and I'll have x squared minus 3x minus 18 equals 10. As soon as I see an x squared and an x, I want to get that equal to 0. So I'm going to subtract over my 10 since x squared is positive. I want to leave that on the left side. And I get x squared minus 3x minus 28 equals 0. Now I want to try to factor this. So do I have two numbers that multiply to negative 28 and add to negative 3? I sure do. So I can go straight to guess and check. So I can do 7 and 4. I want a negative 3, so it's going to be negative 7 and positive 4. Draw my line. Set each equal to 0. And now I have two answers. Want to make sure none of them are these ones we said we couldn't have. I didn't get a 3 or negative 3, so I think that they will both work, but I should always check in my calculator just to be sure. And if this was multiple choice question on the Regents or a final, then you could just type in use this check to figure out the answer. So in for y1, you're going to put the original left-hand side, so 1 minus 3 over x minus 3. y2, you're going to put your right-hand side, so 10 divided by x squared minus 9. Always use the originals. So go to your calculator and make sure you try this on your own. It's really important that you do it, that you actually type it in. So 1 minus alpha y equals 3 over x minus 3. And then on the other side, alpha y equals 10 over x squared minus 9. And then I'm going to go to my table. And if you wanted, you could do second window and start your table at negative 4 at your answer. And at negative 4, we check here. It's a little blurry there, but it should say 10 over 7. That didn't help at all. And then at 7, also checks. We have 1/4 and 1/4. So to show your check, to show your little table here, you just need to show the two answers. So at negative 4, at negative 4, we had 10 over 7. And then at 7, we had 1/4 and 1/4. So they both check. So we have two different answers for this one. All right, let's try another one. 2 over x minus 4 minus x plus 3 over x equals negative 1 over x minus 4. All right, so first pause the video here and try to find your LCD and also your extraneous roots that you would need to reject. All right, so for your LCD, this one a little tricky. So we have x minus 4 repeated twice. So we only need to include that once. But we also have this extra x. And even though there's an x and x minus 4, that's attached to the minus 4. So you need to include that x separately. So that's my LCD. And I can look here and I say, if I have just an x in the denominator here, I know x cannot equal 0. And what would make this denominator 0? Well, that's if x equals positive 4. So if I get a 0 or a 4 for either of my answers, then I need to reject those. All right, so now I'm going to take this LCD and I'm going to multiply everything through by my LCD over 1. So pause your video here and write that out and then try to cross reduce and see if you can rewrite this as one equation without any fractions in it. So here I have x times x minus 4 over 1. Again, you can use brackets to separate it if that helps you. Minus x plus 3. Now here what you could also do, again, as soon as you see subtraction, is change this to addition and then make it negative x minus 3. So distribute it to everything that comes after that over x equals negative, forgot to multiply. So x times x minus 4 over 1 equals negative 1 over x minus 4 times my LCD, x times x minus 4 over 1. Now go through and see if you can cross reduce. Pause the video if you haven't done it on your own yet. All right, so I've got x minus 4s cancel. Here are the x's cancel, and here are the x minus 4s cancel. Everything in my denominator is either crossed off or a 1. So now I'm going to rewrite it as without any fractions. So here I have an x and a 2 left. That makes 2x. Here I have negative x minus 3 times x minus 4. And here I have negative 1 times x would give me negative x. Now I want to simplify. So first I need to FOIL this out. So pause the video, FOIL that out, and see if you can combine your like terms and solve it the rest of the way. All right, so here we have negative x times x is going to give me negative x squared plus 4x minus 3x plus 12 equals negative x. So now I have like terms here. I have 4 negative 3, which gives me a positive 1x and a 2x. So that'll give me 3x. I have an x squared and an x, so I want to get this equal to 0. So I'm going to add x to both sides. And I also want my x squared to be positive. So I'm going to divide both sides by negative 1, which just will change every single sign. The 0 doesn't have a sign, so that won't change. Now I have an x squared and an x, so I want to try to factor it. So do I have two numbers that multiply to negative 12 and add to negative 4? I do. So we'll take 6 and 2, negative 6, positive 2. Draw our line, set each factor equal to 0, and solve. So I get two answers, 6 and negative 2, neither of which I said I would have to reject. So it looks like I'm going to keep both of them. But what I'd like you guys to do now is pause your video and check this in your calculator. I also want you to write out what you'd type in for y1 and y2 and show me the table for your check. So at negative 2 and 6, what you get for the y1 and the y2. All right, so you should have typed in for y1, 2 over x minus 4 minus, so this should be the original, and then y2 should be negative 1 over x minus 4. And then for both of these, they should check. If you got decimals, which is what I have here, 0.16 repeating, those matched, and then negative 0.5 for both the 6s. And since they both check, we keep both of our answers. If you want to write it as a solution set, it would be -2 and 6 with curly brackets for your final answer. All right. Okay, so now we are on number 3, which is 40 over 3x squared minus 16x minus 12 minus 3 over 3x plus 2 equals 2 over x minus 6. The first thing we want to do is factor everything we possibly can in the denominators. So this one is a little tricky to factor because there's a 3 in front of the x squared. So you guessed it, we're going to need to use p's and c's. So I'm going to do this one off to the side. So I think it's important you guys are able to do p's and c's on your own at this point. So it'd be a good idea to pause the video here, do your p's and c's, and then check back. All right, if you can't do p's and c's, then your p should be -36, which is the product of 3 times -12. C is your center term, which is -16. We're going to rewrite this out as split the middle. So it'd be blank x minus 12. Our two numbers that multiply to -36 and add to -16 would be -18 and 2. If you didn't know how to get those, type in -36 divided by x into your y equals, and then scroll through the chart to look for two numbers that would add to -16. So I put in my -18 and my +2, group the first two and the last two, factor out a 3x from the first set, leaving me with x minus 6, factor out a +2 from the second set. Since x minus 6 is the same in both, we can regroup to get x minus 6 times 3x plus 2. So that's just kind of work off to the side. So now I'm going to rewrite this as 40 over x minus 6 times 3x plus 2. Now, none of these other denominators can be factored. And looking at those and what I just got, I can now come up with my LCD. It's all binomials, so I need to include all of them. Pause it here if you haven't found the LCD on your own yet. It should be 3x plus 2 times x minus 6. So now we're going to take each term and multiply by this entire LCD over 1. So I'm going to multiply this by 3x plus 2 times x minus 6 over 1. And if you want, or you don't have colors, you can use brackets to separate it, or just the parentheses is fine too. And equals, a little tight on space here. And again, multiply this by 3x plus 2, x minus 6 over 1. All right, now you want to reduce, cross-reduce, so you get rid of, clear out all of your fractions. And again, this method can only be done if there is an equal sign. If there's no equal sign, you need to multiply by what it needs over what it needs, so a form of 1. This is not equal to 1 because it's not the same number over itself. So pause the video here, cancel everything out, and see if you can finish this one on your own now. All right, so here everything cancels. Here are the 3x plus 2, and here the x minus 6. Do a double check on the bottom. Everything's either crossed off or a 1. Now I'm left with 40 minus 3 times x minus 6 equals 2 times the quantity 3x plus 2. From here, you should be able to take that on your own to finish. So go ahead and try to solve for x now. So you should have distributed to get 40 minus 3x plus 18. If you didn't get this one to work, make sure you did that because that's a very common mistake, forgetting to distribute that negative to get positive 18 equals 6x plus 4. Combine your like terms, and I'm going to hope that you guys did that on your own. So we get 58 equals 9x plus 4. Subtract your 4, divide by 9, and we get x equals 6. So now take a moment here to check this in your calculator. Okay, so in for your y1, you should have typed in your left-hand side here. So 40 over 3x squared minus 16x minus 12 minus 3 over 3x plus 2. In for y2, 2 over x minus 6. And then you're just checking at 6. Now you'll notice here that it gives us an error. So this one does not check. So we're going to reject it, which means it was our only answer. So if we're rejecting our only answer, this problem has no solution. There is no value for x that will work here. Now, why did we have to reject that? Well, that's what I was talking about before. If at the beginning you take a look here and find out what you can't have, we can't have x equals 6 because it would make this denominator equal to 0. Okay, and we also can't have x equals negative 2/3. So if you set your denominators equal to 0 and solve, those are the numbers you can't have. If you forget to do that, it's okay, as long as you make sure to check it at the end and see that you got an error here, which means you have to reject your answer and you have no solution. All right, let's go through a couple practice ones for you guys to try. Okay, the first one is 5x over x minus 2 equals 7 plus 10 over x minus 2. Pause the video and solve this one, and make sure you check it in your calculator as well. All right, so you should have made this into a fraction, put it over 1. Your LCD here should have been just x minus 2. Multiply everything through by x minus 2 over 1. Cancel everything out. You should have ended up with x equals 2. But then once you checked it and put this, your 5x over x minus 2 in for y sub 1 and this in for y sub 2, it shouldn't check. Okay, so sorry about that phone again. So I was saying that you got you should have gotten x equals 2 for this one. And then when you check it again, you should have gotten those errors there, which means it does not check. Even though they're both errors, it does not check. You would have to reject this. So the answer here should be no solution. Okay, and on your paper, I want to see all of the work. So multiplying through by your LCD over 1, canceling out, writing out your new equation, and solving that. All right. Let's try, let's do a little bit of mix. So I'm going to add in a couple others that aren't all equations. So the next one is this. So use your chart if you need to decide what method to use. Pause your video and solve this one, or not solve, but simplify. All right, so this one you should have noticed that it was a complex fraction. You have fractions inside of fractions. So as soon as you see fractions inside of fractions, you should be thinking LCD over 1. So your LCD here, looking at my denominators, a 6, a 1, and a 3. So start counting by 6s until everything goes into it. Well, 6, 1 I can make into a 6 by multiplying by 6. 3 I can multiply by 2 to become a 6. So my LCD is 6. Your LCD will never be smaller than your largest number. So that's why if I take that number and I start counting by that number until all of these go in evenly, then that will help you to find your LCD. So then you would multiply everything through by your 6 over 1. If I didn't say so already, I'm sorry, pause the video and solve it and see if you can do it completely on your own. If you couldn't, now's when you would take your LCD, multiply everything through by 6, clear out your fraction. Your final answer, it actually simplifies down to 1/2. Again, I should see the work for that one on your paper. Next, simplify x plus 5 over x minus 5 minus 3 over x plus 5. Again, look at your chart. When I'm talking about the chart, I'm talking about this right here to decide what you're going to do here. and then use that to solve. So decide which one you're in, need over need, LCD over 1, LCD over 1. So this one you should have decided you're doing a rational expression, so adding and subtracting with no equal sign. So you needed your LCD. Here should have been x plus 5 times x minus 5. Multiplying this one, so this is the only one that's really different. So when you have adding and subtracting with no equal sign, so you're going to multiply the top and the bottom by x plus 5. So you would do x plus 5 over x plus 5 on this side, and here you would do x minus 5 over x minus 5 here. Remember, distribute in the top, and then keep the denominator in the factored form. Your final answer here should be x squared plus 7x plus 40 over x minus 5 times x plus 5. And that would be as far as you can go for that one. All right, do a couple more. 4x plus 1 over x plus 1 equals 12 over x squared minus 1 plus 3. All right, so here, pause the video and solve for x. All right, so first thing you should have done here is factored your denominator, x squared minus 1, put this over 1. This could be factored in x minus 1, x plus 1. Your LCD should have been x minus 1 times x plus 1. And then multiply through everything by your LCD over 1. And then make sure you cancel everything out. This one, you do have some stuff you need to FOIL. It does get a little tricky, even in your equation, so take it step by step. Your final answer here, you should have gotten 5 and -2. And then make sure you check those in your calculator. Anytime you have an equation, check it in your calculator. Here, the ones that would not check would be positive and -1, because those are what would make your denominators equal to 0. So these both should check. Again, this is a little bit of a longer one. Make sure you take your time and let me know if you have any questions on that one. And then our last one here is 5 minus x squared in the denominator divided by x squared plus 2x over x to the 4th minus 2x squared minus 15. So really the hardest part about all these problems is when you put them all together, knowing what to do. So this one is actually not on your chart. This one is division. So when you have multiplication or division, that's when you should be thinking factor cancel. So pause your video. Remember, with division, you want to keep, change, flip. This one's also a little tricky here. It's 4 terms. So give this a try on your own and then come back to check your answer. All right, so this part here, make sure you factored by grouping. So group the first 2 and the last 2. And when you do that, you actually would end up with x squared minus 4 times x plus 2. And then you can factor the x squared minus 4 into x plus 2, x minus 2. Make sure you do keep, change, flip. So here you're going to factor x to the 4th minus 2x squared minus 15 in the numerator. So here would become x squared and x squared. What multiplies to -15 and adds to -2, -5 and +3. Here, take out your GCF of this numerator, leaving you with x plus 2. Over here, like I said, I would want to see your work, but I'm going to jump right to the answer here. Over 5 minus x squared. And then you can cancel things out. So here, just remember when you cancel x squared minus 5 and 5 minus x squared, you need to replace that with a -1 because they're subtraction. Same exact numbers, but in the wrong order. And then here our x plus 2's can cancel. And we are left with -1. I'm going to put in the front. We have x minus 2 on the top, and x plus 2 on the top, and an x squared plus 3 all over x. And that would be your final answer. All right, and that is it for today. So seeing them all mixed up, really important to go back and make sure as you do your homework tonight that you can figure out what method you need to do all on your own and have that down, because that is really the most challenging part for most students. All right, and if you do have any questions or if you had any trouble on these practice problems, please be sure to let me know. All right, pie out.